This video on fractions in the arithmetic chapter is on mixed numbers. We talked just a little bit at the very end of the last video about changing something to a mixed number, so we'll look at that process again. But let's first look at graphing fractions and mixed numbers on a number line. Students have a lot of trouble with this. Now my number line is so wide I can't really get it all on the screen at once, but as you can see it goes from -4 over to +4 with 0 in the middle. The -2 and the 2 are labeled. So before you begin to locate these fractions, the first thing you want to do is label the rest of the marks. So if it goes from 0 to 2 in the positive direction, then I know that this mark is a 1. And by the way, label the positive side only and then go back and just copy that onto the negative side. It's just a reflection. If this is 2 and this is 4, then I know right here is 3. Now between 0 and 1, there's only one mark, so I know it's 1/2, 1, 1.5, 2, 2.5, 3, 3.5, 4. So I know that each mark is a half, and now we're going to duplicate that over here on the negative side. So this is -1/2, -1, -1 and 1/2, -2, -2 and 1/2, -3, -3 and 1/2, -4. Now I want to show you one more thing. Since each of these lines represents a half, we could also count in halves, and I'm going to do that in a different color. So I could say this is, let's do the positive side first. I could say this is 1/2, 2 halves, 3 halves, 4 halves, 5 halves, 6 halves, 7 halves, and 8 halves. So those are equivalent to the way we wrote them before. This would be -1/2, -2 halves, -3 halves, -4 halves, -5 halves, -6 halves, -7 halves, and -8 halves. And now that everything is labeled, that will help us in locating our fractions that we were given. So the first one we're given is 1/2. Easy. It's already labeled, so it's right there. -3/4. Well, I know it's on the negative side, but I don't have anything divided into fourths. To divide them into fourths, I would have to cut each of those halves in half, and we can do that, and then count by fourths. So it would be -1/4, 2/4, -3/4 is right here. It's in between -1/2 and -1. Going to come back to this one in just a second. Let's go -3. That's an easy one because it's already labeled, so no problem. And then -3 and 1/8. I don't want to have to divide these into eighths. I just know that it's a little bit more negative than -3, so I'm going to say -3 and 1/8 is about right there. If I was doing this on a test, I would just want to make sure that you put it on the correct side of -3. It's more negative. Not on this side, but on this side. Now we have 2 and 2/3, so that's on the positive side. So I know it's bigger than 2. Here's 2. 2/3 is more than 1/2, but it's not as big as 3. Now if you think about it, if you want to be really exact, what's exactly in between is 2 and 3/4. But 2 and 2/3 is a little bit less than that. So I'm going to estimate 2 and 2/3 to be right about there. It's a little bit more than 2 and 1/2. So you're just sort of estimating. All right, let's look at changing a mixed number to an improper fraction. And you will see this big 2 3/5 I've got on this side. It shows sort of a circle thing that you do. When you have a mixed number, meaning a whole number part and a fraction part, you start with the denominator and you say 5 times 2 is 10. So this is a times, plus 3 is 13 over 5. So it would be 13 over 5. Very simple to do. So let's try this. 9 times 4 is 36, 37, 38 over 9. So it's 38 over 9. That's the same way to say 4 2/9. 11 times 1 is 11 plus 8 is 19 over, it's always back over the original denominator. 35 plus 2 is 37 over 7. Oops, that was supposed to be a 3. 37 over 7. Now let's look at going the other direction. If you started with the improper fraction, how do you get back to the mixed number? What you do is you divide the denominator into the numerator. How many 7s would go into 30? Well, there's only going to be 4. That makes 28, and there would be 2 left over. 2 what? 2 7s. It still goes back over the original denominator. You can check it by doing the circle thing. 7 times 4 is 28, plus 2 is 30 over 7. It checks. 15 goes into 16 one time with 1 left over. 1 what? 1/15. 6 goes into 84. Now you may not know that. You may actually have to do this kind of a deal, but it happens to go 14 times with nothing left over. Goes evenly. All right, so let's look at some operations with mixed numbers. So we're going to look at multiplying and dividing first with mixed numbers or whole numbers. And basically it says write any mixed or whole numbers as improper fractions and then multiply and divide just like you always do. So let's bring that down and look at the next page. We have multiply 3 1/3 times 7/8. First thing you want to do is change that to an improper. 3 times 3 is 9 and 1 is 10/3 times 7/8. And now that I am multiplying, I'm allowed to cross cancel. Is there anything that goes into 10 and 8? Yes, 2. 2 goes into 8 4 times. It goes into 10 5 times. Nothing goes into 3 and 7 other than 1. So we're just now going to multiply 5 times 7, 3 times 4. Now I prefer to leave it as an improper, but you can change it back to a mixed number. How many times does 12 go into 35? It goes 2 times, that makes 24, with 11/12 left over. But it's safer to leave it as an improper, because if you have that part right, but you change it to a mixed number and you do it incorrectly, I'll have to take points off for that. Okay? Whole number, we're just going to put over 1. Now let's rewrite that so things are lined up a little better. 3/4 times 20 over 1. Since I am multiplying, again, I can cross cancel. 4 goes into 4 once. It goes into 20 5 times, and I end up with 3 times 5 is 15 over 1 times 1 is 1. Don't have to show that denominator. Okay, let's do the next one. It says check by estimating. I'll show you what that means in just a second. 3 times 1 is 3, 4 5/3 times 4 times 2 is 8 and 1 is 9/4. Let's cross cancel. 3 goes into 3 once. It goes into 9 3 times. 5 times 3 is 15 over 1 times 4 is 4. Changing that to a mixed number, 4 goes into 15 3 times with 3/4 left over. Now when it says check by estimating, 1 2/3, if you think of that number line, 1 2/3 is closer to 2, so that's about a 2. 2 1/4 is closer to 2 than it is 3. So 2 times 2 is 4, so our answer should be close to 4, and it is. So that's all you're doing, is just sort of seeing where these are closest to on the number line. All right, 7 is a whole number, so I'm going to put it over 1. This one we're going to change to an improper. 14 times 2 is 28, and 11 is 39 over 14. I can cross cancel. 7 goes into 7 once. It goes into 39 twice. And 14 twice, sorry. My brain went too fast. I end up with 1 times 39 over 1 times 2 is 2. Or if you want to change it to a mixed number, 2 goes into 39, 19 times with 1/2 left over. I prefer that. Let's look at dividing. First thing we want to do is this over 1 so that we then can do keep, change, flip. Keep the first, change to multiplication, flip to the reciprocal of the second. Now that we're multiplying, you can see if you can cross cancel. You can't, so you just multiply and get 3/20. Let's try it with a mixed number. We are going to rewrite this as a division problem, 11/18, still as a division problem, but change this. 6 times 2 is 12 and 5 is 17/6. Now we're going to keep, change, flip. So change it to an improper first. So 11/18, keep, change, flip, 6 over 17. I can cross cancel. 3 goes into 6 twice. Actually, 6 goes into 18, doesn't it? 6 goes into 6 once. 6 goes into 18 3 times. I didn't have the GCF at first. 11 times 1 is 11. 3 times 17 is 51. And that is a proper fraction, so you can't change that. Let's rewrite this first as impropers. 3 times 5 is 15, 16, 17 thirds, divided by 9 times 2 is 18, and 5 is 23 ninths. Now, keep, change, flip. So keep, change, flip to the reciprocal, cross cancel, and multiply, and we end up with 51 over 23, and I'm going to leave it as an improper fraction. It would change to a mixed number, but I think it's easier to leave as an improper. All right, let's look at adding and subtracting. Same rules apply. Change them to improper, and then common denominator. Now, this tells you a different way to do it. It says add or subtract the fraction parts, add or subtract the whole number parts. You can get into some trouble with that. So we're going to change them all to impropers. 3 times 2 is 6, and 1 is 7 thirds, plus 43 eighths. Now I'm going to find the LCD of 3 and 8, which is 24. What do you do to 3 to get 24? Times 8. So I do that in the numerator also. What do you do to 8 to get 24? Times 3. So I do that here too. That's a big number. Now I have my common denominator, but I have to add 129 and 56. 15. We get 185 over 24. Changing that to a mixed number is not very pleasant, but when you do, you divide 24 into 185. So you actually, let me do this down here. You do this, and 24 into 185. Oh, it's 185. I believe it goes 7 times. 7 fours are 28. That's a 16. And then we have 17 24ths left over. So that gives us 7 and 17 24ths. So now maybe you see why I like leaving them as impropers. Let's do this one. Again, let's change them. 7 eighths are 56, and 3 is negative 59 over 7. You keep the negative. 105, 106, 107, because it's 21 times 5 plus 2, 107 over 21. I don't like the looks of this one, but it is easy to find the LCD here. It's 21. So the second one is good. What do you do to 7 to get 21? Times 3. So when I do 3 here, I have 3 9s are 27, carry 2, 3 5s are 15, 16, 17. That is negative. Now I have my common denominator, so it's going to be over 21. I have more negative than positive, but I can simplify this by dividing by the GCF of 7, negative 10 over 3. And now if you want to change it to a mixed number, it's much easier with those small numbers. I don't want to divide 21 into 70. I'd rather divide 3 into 10. And we have negative 3 and 1/3. Now it says estimate first, so let's just see what this would have been. Negative 8 and 3/7. 3/7 is not even halfway to negative 9, so I'm going to call this negative 8. And 5 and 2/21 is about a 5, so we should have gotten something close to negative 3, and we did. All right, 2 more. Change them to impropers. 14 times 7, so 14 times 7 is 98, and 3 is 101 over 14. 7 times 3 is 21, and 6 is 27 over 7. You can see that your LCD is 14. Good, I don't have to do anything with that one. What do you do to 7 to get 14? Times 2. 2 times 27 is 54. 101 take away 54. So 101 take away 54. So this becomes a 9. 7 and 4 is 11. 1 and 4 is 5 and 5 is 10. That is correct. So what we have is 47/14. If you wanted to change that to a mixed number, I think it comes out as 3 and 5/14. All right, let's look at this one. It's 14 over 1 minus 7/8 or 59/7. The LCD here is 7, and I've kind of run out of space. Let's see if I can squeeze this on in this last little corner I've got here. We're going to change this to a 7 by multiplying by 7, and I get 98 minus 59. So 98 minus 59 is 39. So we get 39/7. That one's not too bad to change to a mixed number. It's 5 and 4/7.